Welcome to this video, guys. Today we are going to be solving this exponential equation. All right, but before I jump into the solution, I believe you would want to attempt this problem. So if you feel very confident in your mathematical skills, why not pause the video right here and go attempt this problem by yourself? All right, and then we can compare our answers at the end of the video. All right, pause the video right now and go attempt it yourself. I believe in your capability. All right, welcome back. Let's continue in this video. So what we have is 2 raised to the power of 2x minus 5 times 2 raised to the power of x plus 6 is equal to 0. Okay, this expression can also be written in this form. All right, 4 to the power of x minus 5 times 2 to the power of x plus 6. All right, because if you check the first term, it also can be written as 2 raised to the power of 2 is actually 4. Right, so whichever way you see this kind of question, you already know that both of them are the same. All right, but this first expression is very common. This one is not so common. So in an exam situation, the examiner would likely twist this question to this, and you might be confused. If you notice, 4 can be raised to the power of 2. All right, so whichever way the question comes, you know how to tackle it. But this is what we do in this case. We use this first expression. So if you realize that 2 raised to the power of 2x can be written as 2 raised to the power of x, and then you can bring out the 2. All right, and then you have minus 5 times 2 to the power of x plus 6 is equal to 0. This kind of equation occurs all the time, and if you notice, 2 raised to the power of x occurs in this equation 2 times. So you can simply substitute 2 raised to the power of x for another later. So let's say let 2 raised to the power of x be given as y. Since we cannot solve x directly, let's use another variable, substitute it into this equation, and then let's work out something. So when you fix 2 to the power of x into this expression, you get y squared, and then this becomes minus 5. Anywhere you see 2 to the power of x, you put y. All right, and plus 6 is equal to 0. You see that this equation has been transformed to something else entirely, and this is already a quadratic equation. I hope you agree with me, a quadratic equation, because it is raised, y is raised to the power of 2. A quadratic equation can be solved using different methods: factorization method, the formula method, and completing the square method. All right, so let's use factorization method. We replace the middle term here with 2 terms, that's such that when you add them together, you get the middle term, and when you multiply them together, you get the product of the first and the last term. So this expression becomes y squared. If you look for those terms, you get minus 2y minus 3y plus 6 is equal to 0. Right, so what you simply do is you take out y. So y is common here in this part, so y comes out. We are left with y minus 2. All right, so minus 3 will come out, the coefficient of y. We are left with just y, and then this plus becomes minus. All right, since we have taken out minus, and then we are left with 2 in this case. 3 into 6 is 2, which is equal to 0. And you notice that y minus 2 is common on both terms, so you bring it out first. Okay, and what you are left with here is what? Y. What you are left with here is what? Minus 3 is equal to 0. You see, so from this equality sign, you can confidently and comfortably say that y minus 2 is equal to 0. That would mean that y is equal to 2, and then y minus 3 is equal to 0, and that would mean that y is equal to 3. So these are the values of y and x. Of y's, I mean to say, these are the values of y. But we are not looking for y, we're actually looking for x. So what you simply have to do in this case is to substitute into this equation, right? Is to substitute when you have y is equal to 2. So since y is equal to 2, we know that y is equal to what? 2 raised to the power of x. So what you can simply do is to say 2 raised to the power of x is equal to 2, and this is to the power of 1. This implies that what? X is equal to 1. All right, you see that? And then this is the first case. This is the first case when y is equal to 2. So what of the second case where y is equal to 3? So when y is equal to 3, we know that y is equal to what? 2 raised to the power of x. So we equate these two, and then we have 2 raised to the power of x is equal to 3. But unfortunately, we can't raise x to the power to the base of 2. Okay, so we have to apply logarithm. So we can take the logarithm of both sides, and that becomes log 2 to the power of x is equal to log 3. I hope you agree with that. And then let's keep on going. And what would that mean? From the law of logarithm, this will multiply the logarithm. So x, we have x log 2, right? And that will be equal to log 3. Okay, you would realize that you can divide both sides by log 2. Okay, when you divide both sides by log 2, it disappears from this end, and this becomes log 3 over log 2. All right, so another way of expressing this, you can also rewrite this by the law of logarithm. Since the logarithm of the top, the base is to the base of 10, because they have a common base, you can simply write this as log 3 base 2. All right, can you see that? Log 3 base 2. This becomes our answer. So at the end of the day, therefore, I can confidently say that x is equal to 1 and log 3 base 2. These are the two possible solutions of this equation. I hope you got something very close to this, but if not, why not watch the video again and find out what you did wrong. And then if you have any question for us, you can drop your comment in this comment section below. Thank you for checking out this video. We'll see you in the next one.